Okay, so we're picking up where we left off. So we've taken our integral of the square root of tangent of x, and we've used u substitution to turn it into this integral right here. So basically now, I still can't integrate this directly. I'm going to need to manipulate it a bit into getting these into a form that I can work with. Now these next few steps may not seem quite so intuitive, but as we examine the logic behind it, we can see that for one, it does make sense, and second, we can start to see a pattern that will emerge, and we can use this pattern for many integrals of this kind, and we can always take approaches like this. One of my main problems is I don't like the fact that I have u's here and here, but nothing here. I really would like to get rid of this u squared in my numerator. And the reason I would do that is I'm trying to get this into a format where I can use some of my familiar integration techniques, something like a u substitution or a trig identity or a partial fraction, and as it is currently set up, I can do none of those things. So first things first, I want to get rid of this u squared. So I have 2 times u squared. How do I get rid of doing multiplication? I do the opposite of multiplication, which is division. So I'm going to divide all 3 of these terms by u squared, so this one cancels out. Now if I do that, I end up with just a 2 in my numerator. And here in my denominator, 2 of the u's cancel out of this one, and I'm left with u squared. And 1 divided by u squared is just, of course, 1 over u squared du. Now as I continue on with this, here's the part where it gets very tricky right here. I need to break this up into some pieces right here so that I can manage this a little bit better. So I'm going to observe that obviously 2 is equal to just 1 plus 1, so I can break this up into 2 pieces. 1 plus 1 over u squared plus 1 over u squared du. And in addition to that, I'm going to take this term here, which is causing me so much trouble right here, and I'm going to do something else in the numerator with that. I notice this is equivalent to 1 plus 1 over u squared plus 1 minus 1 over u squared, all over my denominator u squared plus 1 over u squared du. Let's think very clearly about how to connect with this. I can do this because I have added this term and subtracted this term, so of course those cancel out, and 1 plus 1 is the same as this, does equal 2. So this right here is still equivalent to the 2 I have right here. 1 plus 1 equals 2, positive 1 over u squared minus 1 over u squared equals 0. So why is it that I want to do this? Because I want to separate this out into 2 distinct integrals that I can start doing some more substitution on, and this is setting me up to do that. So I notice this is equivalent to 2 integrals. Note, of course, when we're adding and subtracting integrals over the same denominator, all in the same variable, we can break it out into multiple integrals. So I'm going to take the first piece, these first 2 terms, so now I have 2 distinct integrals that together sum up to my previous one.